Okay, this is our example that we are going to continue working with Amitrack dataset. First of all, we need the libraries, all of them. Sybil, tidyverse, Fable, and Slider. Slider is part of FPP3. So to install the library FPP3, you can just install it here, F3. As we said multiple times, to install the packages, you do it in the console. To load the libraries, you have to come here. After that, let's get into our dataset, Amitrack dataset. We know that the Amitrack contains only two variables. We need to change it to Sybil, not keep it Tibble. It's data frame now, so I'm going to change it to time series data frame as we did before, and the index is the month. So we have Amitrack time series, we have the month, we have the ridership, and we plot this before to see how the data look like. So we know that we have a trending going on. It's kind of a U-shaped, and we have seasonality every 6 months. So let's continue now and do the moving average. Let's calculate the moving averages. Okay. So because we have seasonal data set, we're going to use a moving average to be for 12 months. For 12 months, okay. So we're going to add 12 data observations to get our moving averages. So the beginning, and you can change it. You can try 3 and 5 and so on to see what's the difference between detailed versus smooth data, okay, curves. We are going to do 2 moving averages. The one's going to be centered moving average for 12 months. The other one is going to be for the trailing moving averages for 12 months. If you do the centered, that means you're adding 5 before and 6 after the point of interest. If you do trailing moving averages, you do 12 before your data point, okay? So I'm going to call it a new data set. I'm going to call it moving averages for 12 months, okay? So I'm going to call Amitrack time series pipe, and I'm going to add these calculations. So what's the point? The point we are going to calculate. We have the riderships. I'm going to calculate 1, 2, 3, 4 up to 11. The previous with the point of interest. This one, we're going to add all of them together to then divide by 12 to get the first average. Then we're going to do the rolling, just moving on. Then from here up to here, add all of these data, divide by 12, get the answer here, and so on. We are going to see it just in a second. This for the trailing. For the so-called, for the centered, no, we're going to take 5 before, 6 after. So 1, 2, 3, 4, 5 before. So this is my data of interest. 5 before plus this one and 6 after. We get the answer. We put it here and so on. We continue rolling over. Okay. So now we are going to find the centered. I'm going to mute it. Let's mute it. Add a new column. Okay, muted. The first column I'm going to add is CMA, which is the centered moving average 12. Okay, this is the name of the new column. Okay, so to calculate the moving average, centered moving average, I'm going to use a function which is called slide double. And inside the slide double, I'm going to have many things. Number one, I would like to specify what kind of column, which column you're going to do the averages for. It's going to be ridership. After that, what kind of function I'm going to do. So what kind of things? Am I going to do the sum, or I'm going to do the mean? I'm going to do the mean, which is the averages, right? After that, I have to specify, if you look at here's the things, dot before, dot after. So these are important stuff. So dot before, how many points I have to look before my data set? 5. Dot after is going to be 6 because my data set is going to be in the middle. Okay. After that, we want to add something which is complete argument. So complete argument, we want this to be true. That means if you have a complete data, then you do the averages. Other than this, you don't do that. This is the first column we have added, which is mutate the first one. After that, I'm going to add another column. So let's add another column. After we finish, let's add another one. Let's add another mutate. Let me just copy this carefully. I would like to add the trailing moving average 12. Again, slide double, ridership, calculate the mean. But before my data set, calculate the 11. After is nothing, 0. Okay. So now what we are going to mutate, we're adding 2 calculations. Moving averages Slide double is the function because it's doing this on a rolling basis. To keep adding, and before and after. Someone's going to tell me, you said the 12. Yes, because 11 plus our time series observation and point is 12. 5 before myself, the point in the middle, and 6. So we have 12. So we have the data in the middle. So let's run this. We have MA12. We have 4 variables because we added the new guys, right? So we have the centered moving average 1, 2, 3, 4, 5, right? Plus 6 after this. 1. This is mine. Then we have 6 here. This is 1, 2, 3, 4, 5, 6. This is our data set, first one. Then 6 after these. We got the average of the first 12, right? We put the answer here. After that, we got 1, 2, 3, 4, 5, and this guy, 6. Then we got another 6. We take the average, we put it here. Then we start from the third one. 1, 2, 3, 4, 5, 6. This is the middle one. Another 6 after that. We add all of them, divide by 12, you get this guy. And we keep doing this until we what? We just end up having this. Because after that, you will not have 6 points before after this. For example, if you come in here, we have 5 before. Do we have 6 after that? We don't. So we finished up to here. So this is my new data set, which is containing the averages. Okay. What about the trailing? The trailing, we just look at the data in the past, not the past and the future. That's why if you look at the trailing, we're going to end up having everything. Look at this. So we have the whole data set, because if you look at the 12, we just add the averages of the previous 12, okay, from here. So this is the time series, the averages that we have produced. The goal is to smooth. One is to smooth, the other one we can just, what's it called? The other one we can do forecasting for the next observation. After that, we are going to plot. So let's plot the moving averages on the time series, on the original one, okay? So we're going to see like 3 curves, okay? So what to do first, as we did before, we're going to use autoplot, and I'm going to take the data from MA12. I'm going to pass it to the autoplot. So what kind of data I'm going to have in the autoplot? Ridership. This is my original data set. So if you do that, you're going to have ridership. So autoplot understands that all the index is the month, right? So I would like to add more too, guys. I'd like to add geom line. I would like 2 lines. The first one contains the CMA12. The other one's going to contain the TMA12. Okay. So I'm going to add another layer for the autoplot. So the second layer is going to be geom line, and I'm going to map AES, aesthetics. I'm going to map the x-axis, which is the month, with the y. Which y? We call it CMA12. Okay. The second one, I'm going to do another mapping, which is geom line. Then I'm going to map what? I'm going to add another line and map what? I'm going to map x with which y? TMA12. So if you graph these, do you have an issue here? It says there's, oh, here we go. So if you graph these, we have these 3 lines. To give them different colors, we can add a different color for each level. So let me add color. If you're not sure it's color or COL, you just try. I'm going to choose red here, and I'm going to color the second one. Is it going to be inside the aesthetics? No, because we are not doing any map between anything. So we're just giving colors to the same time series. So it's going to be probably blue. Let's say. So now we have the 2 moving averages. So using 12 as a window width, and look at from where they are starting, everyone. This is starting after the first, after the 5th observation, and the other ones start after what? After the 12 or 11. You can change the labels, as we said. You can add, probably, if you'd like to add labs. So y is going to be, just give it, right? It's just ridership. I'm going to keep it. The title, probably you're going to give it a title equal. So Amtrak ridership. Okay. What if you'd like to change the scale of x? So the scale of x, we have only 2 years. We see 2 years. I'm going to see more than this. I use another layer called scale x. You can do this for y. Scale x. Scale lag is going to be year, months. It's just nothing as just the year, month. Sometimes you have a quarter, etc. And I have to specify the breaks here. So the data breaks, it's going to be 1 year because we have yearly. You can see 2 years. We can put 2 years. And the labels, just keep the labels as they are, just as years. So years, and here we use the percent sign and Y, capital Y. So we have the years. If you'd like to have every 2 years, you just change 1 to 2. So you have every 2 years for the which is clearer. And let me keep it 1 is good. So we have the years only. So that's why we have this, the labels. And look, this one starts from after the first year. This one, the middle, almost. So the red one is actually the centered, and the blue one is the trailing, okay? Next idea, we are going to do differencing now. It's a bit more complicated, but let's just do it and see how it goes. Differencing. And this is part of the data differencing. This is part of data wrangling techniques that you learned already. And for differencing, what is the goal now? The goal is to find the lag one, as we explained in the lecture, lag 12 and lag 12, then 1. So we're going to subtract every 2 consecutive points. We get the point, and we are going to subtract every 12 points. We get this data, and we are going to have 12, then subtract 1. So we're going to do detrending, and we're going to do de-seasonalizing, and we're going to do both of them at stationary data set, okay? So at the beginning, let's just start with the very simple stuff. So let's just start with, let's call them lag data. This should be straightforward because this is going to be taken from Amitrack time series, pipe. I'm going to mutate a new thing, 3 things. So I'm going to do the calculations, mutate. I'm going to subtract ridership minus the lag ridership, comma 1. So it's going to be just subtracting YT minus 1 and so on. So let's first, again, I'm going to create, this is Amitrack time series. So what I'm going to do here, I'm going to come this one here. First one is going to be nothing because I have nothing to subtract, right? I have nothing to subtract from the previous one. Then we come in here. I'm just going to find the difference between this guy and this guy. Just subtract this minus this, place it here. Then we move on. I come here, subtract this minus this, place it here. Then move on here. This minus this. This is lag 1. Lag 12, we're going to go back 12 points, okay? So 1, 2, 3, 4, 5, 6, 12. We subtract this minus this, okay? The next one, you go to 12 in the next one and subtract the next one minus this one, and so on. So we are going to calculate lag 1. I'm going to use lag 1. So the first mutate, let me use enter here because I'm going to mutate multiple stuff. Lag 1, I'm going just to subtract ridership minus lag, a function called lag, ridership 1, okay? The previous one. So go to the, let's say, second one, observation, minus the one that before this observation. Ridership 1, that one that before this current observation. So let's just do the first one and see. So lag data is here. This is lag data. So what happens? We go to the first one, ridership. Then we go, there's my code, ridership, the first one, minus lag, ridership, this value, the first one, which is, what's the first one? 1708. 1708 minus lag 1708, comma 1, the previous one of this point, nothing, NA. Then we move to the second one, 1620. So 1620 minus lag 1621. So go back 1 observation before the 1620, which is what? 1708. Subtract them, put the answer. After that, go to the next one, 1972. 1972 minus lag 1, go back 1, was the previous one. It's this guy, 1620. Subtract them, get the answer. This guy minus this, put the answer. This minus this, put the answer. This is lag 1. Let's do lag 12. This is the detrending. Now, we assume. Now, lag 12, because I'm adding and mutating, I'm mutating multiple guys, so I'm just going to do comma, okay? Can I do mutate just one? Yes, we can. Different. Can we separate them? Yes, you can. Maybe I separated them there, just for simplicity probably. Can you put them together? Yes, you can. 12. So 12 is going to be, again, ridership, but we're going to go back 12 now. Comma. Before comma, let me see how it goes. So again, lag. This is the lag 12. Lag 12, what happens? Go to number 1, ridership, minus ridership, this guy, comma, 12. Go back 12 points. Can you see 12 points? Nothing. No. An A, up to here. 13. So ridership 1640 minus lag 1640, 12. 1, 2, 3, 4, 5, up to 12. This one. Can we? Yes. So subtract these two values. Look, January 1991, January 1992, right? So keep doing that. Keep doing that. February 1992 minus February 1991, and so on. So keep lagging in 12, subtract 12, then give me lag 12. This is the difference. Next one, I'm going to be careful now because I'm going to copy and paste. However, I'm not going to subtract riderships. I'm going to subtract lag 12. I'm going to lag 12 once. So my goal now is to go to lag 12, and do it once. So I'm going to go, where is it? Lag 12, come here. Subtract the previous one, nothing. So come here. Subtract the previous one. So this minus this. We get the answer here. Then come here. Subtract the previous one. Put the answer here. So we find the difference between every consecutive points in the lag 12. So we do both of them. I'm going to see both. So I'm going to call this one 12, 1. We do 12, then 1. We go to 12, then we lag it once. One more time. Let me run and see this lag data. Look at this. Negative 63 minus negative 93 is 30. Negative 81 minus negative 63 is this, and so on. So we got lags differencing. So we are assuming to first detrending, deseasonalizing, and here we deseasonalize, then we detrend, we're going to get stationary for this guy. So we will be assuming that this one's going to be stationary. So that's why we are going to graph them. Okay. So the first step, finding the differences. So we found the differences. Okay. After that, we are going to graph them or plot them. So I'm going to plot them to make it easy. What I'm going to do, I'm going to put them in a longer format. I'm going to pivot them in a longer format. So I have only the months. Okay, where is it? This one. Only the months. And I'm going to have these guys, to be in a column. I'm going to call it, let's say, a series or whatever. After that, I'm going to place the values. I'm going to have a longer format. This as a data analyst. So plot them. So let me pivot them. So use pivot longer to have longer format. Why is that? Just because I want to have, when I graph it, I'm going to use wrap, so-called facet wrap format. So I'm going to call it lag data long. Okay. So I'm going to take my lag data. My lag data, by the way, it's a table. It's a table. Okay. Do I need to change it to not sure, by the way. Let me try to use pivot. Pivot longer. This is Dippler, so I'm going to try. So what I'm going to do, I'm going to have all of them. So I'm going to do, first of all, if you have a pivot longer, I'm going to have only 3 arguments inside this guy. The first argument is going to be what kind of columns you are going to squish together, you put together. So which ones? I'm going to have the 3 of them. 3, let me look. Lag data. 1, 2, 3, 4. I'm going to put these all together in one column. So I'm going to call this vector rider. We have to put them in vector ridership. The other one, the name of the other one is lag 1, then lag 12, then lag 12, 1. So I'm going to squish all of these together. I'm going to put them together, and I'm going to use the next argument is I'm going to name this what. So I'm squishing these, put them together. Name this to what? Name to what? The name is going to be only series, or maybe riderships. No, ridership is not accurate because we have differences here. And I'm going to do values too. The other argument is going to be values too. The values, I'm going to call them, because I'm going to take the values inside these, by the way. So I'm going to squish these to put them here. I'm going to call them series. Then I'm going to take all of the values here. I'm going to put them in the second, third column. So first column is going to stay the same, month. The second one is going to be series that contains ridership, leg 1, leg 2, etc. Then here we are going to have the values. So I'm going to call it probably values. Okay, ridership. I have leg data long. We have it here. So we have a long data set right now. Let me look at this. It's still simple. Okay, this is good. So we put them in a longer format. Why is that? Because I would like to graph it to be straightforward and easier for me. So let me plot the time series quickly. Plot the time series and the differences. Okay. So I'm going to go to my leg data long and I'm going to throw it in the ggplot. My ggplot, I'm going to, if you have ggplot, I'm going to as aesthetics. I'm going to map what to what. Aesthetic, let me look at. I'm going to map the month, okay, to the values. Months to the values, okay. So month is going to be my X and value is going to be my Y. If you run this, let's see how it goes now. Nothing, because I did not start with any line. So we have to add geom line. So nothing inside because already I mapped the month versus the value. Just I want to see the lines. This doesn't make any sense right now because it keeps repeating everything. So I have to use facet trap. So I'm going to wrap them. I'm going to separate them based on the series. Okay, I'm going to separate them. So I'm going to add facet trap and I'm going to use tilde series. So what's going to happen? Series. I'm going to separate them. Series. Based on the series, let me check this first. Okay, here we go. Now we have issues with this. Now I separated them based on the series, tilde series. I have to work with the y-axis, right? With the y-axis because these are not free. So what I'm going to do, I'm going to change the scales. So I'm going to change the scale. So scales argument can come inside the facet trap. I'm going to having free y. Let's run this. Now we have a free y-axis because this is a ridership. We have a positive numbers, which makes sense. Then we have the what's so called the time series data. So you have a negative and positive. We have leg 1, leg 12, then 1. Look at this. It's exactly the same thing that we did in the lecture, right? Also, excuse me. Also, you can specify number of columns. These are by default, give me 2 columns. Let me try to number of columns. Let's say 1. Yeah, this is 1 column. I'm not very big fan of this. I'm going to keep it 2 or just default it. Just take it off. So you have 2 columns. What else? I'm going to do something we did before, which is the scale of y. So I'm going to take this, I'm going to add it here. 1 year, this is too small to see the years. So let's do 2 years here. Here we go. So we have every 2 years, we can see the labels, right? What else? If you'd like to change the theme, by the way, you can do so. You can just add, if you want to change the color also, you can do so. So check theme, you can do classic, black, white, dark, get a gray, light. Let me use economist, it's not here. Theme, economist, not here. Minimum, okay, minimal is here. This is minimal. What if you'd like to match the legs with colors? So the series with colors, we can map this inside the aesthetics. Any mapping you want to map, it should be inside the aesthetics. So I can do color has to be based on the series. So I'm mapping the color with the series, okay? So run this. It gives me different colors. If you'd like to take this off, you can do theme. You can add theme here, another theme, legend position, position, true or false, I guess, or none. Let me hit the true. Where is it? False, no, maybe none or an A. Yeah, it works, false. Maybe none. Sometimes some words are working. Missing, that's okay. We have warning, we have missing values. You can take off the warning if you don't want by adding this guy. Warning, space, warning. I don't suggest this to be done. False. So no warning. Also, you can change the titles, etc., and change the names. I can change it from here if you from here you can do that. So this is the ridership. Look at the ridership. If we did a lag for 1 year, one point, not 1 year, we get a trend has been removed. If you do 12 months lag, that means we got no seasonals here. If you do 12, then 1, you get, oh, this one is the 12 one. This is the lag one. So we have no trend, but still seasonal. We have no seasonal. Still, we have some trends probably. Sometimes misleading. Now we have a misleading trend. Up, down, up, down. So it's kind of a jiggling down, up, down, etc. 12.1 removes everything. So this is just an example about how to do what's called the moving averages. We did entered, we did trailing, also we did differencing. Thank you.